Okay, good morning to one and all present here. Myself, Harsh Soni, and this session would be moderated by me. So, dear authors and invited guests, on behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the ninth International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2024, Jaipur, India. Okay, so this conference is organized in a hybrid mode. Physical event was held on 19th of December 2024 at Jaipur, India, and today and yesterday was for digital mode. So I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations, and each presenter will be given 8 minutes for the presentation and 2 minutes for the question and answers. So on 7 minutes, I will raise a gentle reminder so that you can conclude your presentation on given duration. There's a one special request for all the authors that you may all please stay connected with us till the closing remark so we can capture the good memories of this virtual conference. Just before we get started, I'd like to introduce you all to the chair for the session. Dr. Garima Sharma is an assistant professor at the Mechanical and Automation Engineering Department at Maharaja Agrasen Institute of Technology, Delhi. She holds a PhD degree in the field of study of factors influencing the performance of service organizations from Delhi Technological University. With over 18 years of academic experience, Dr. Garima specializes in teaching and research in industrial engineering. She has taught a range of subjects. She has authored books on industrial engineering, published numerous research papers in reputed SCI journals, international and national conferences. She has also guided many undergraduate students in various project works, demonstrating her commitment to academic mentoring and innovation. Ma'am, we welcome you for the session.
Thank you so much. Thank you.
All
Can I
right.
start?
Yes, ma'am.
Yes, you can start with the
All
article.
right. I'll just invite the first presenter of the session. First, we have Vaishnavi Lat, and she's going to present on a comprehensive survey on phase lock loop IC design.
I'm Arya, her teammate. Just a second, she's joining. Hello, good morning, all. I am Vaishnavi Nath, and today I am here to present the survey on the PLL IC design. I have worked on this along with my colleagues Arya Mende and Dr. S.S. Market. Moving forward to the introduction, PLLs are critical for the applications like clock generation, clock recovery, data synchronization, and frequency sensing. It has a wide use in mobile applications, wireless communication, etc. The demand for energy efficient and scalable design has increased with the miniaturization of ICs. Is that as we increase the uh, power consumption, the size of the IC has also increased. Integration into SoCs simplifies the design and enhances the manufacturability process. The advancement in technology nodes have improved the power efficiency area, but the new challenges like phase noise and complexity have also introduced. The objectives of our project were to analyze the progression of PLA design across the various technology nodes, ranging from 180 nanometer to several few nanometer technologies, and also its architectures. We also evaluated the trade-offs between the performance metrics like phase noise, power consumption, and jitter. We also introduced challenges and trends for the next generation PLL IC design. Methodology, methodology that we introduced in our project in a survey was we verified plus works on PLL design and performance and different performance parameters. The comparative analysis of power, jitter, phase noise, and chip area are focused in this design. The phase noise refers to the random fluctuation in the phase of PLL's output signal. It was measured in spectral density at specific frequencies. It is measured in the unit dVc per hertz. Jitter refers to something time variation in the PLL's output clock caused by phase noise. It impacts the synchronization and data integrity in time-critical applications. Last, the power applications. The power consumption in PLL is a very important topic, very important point, and the PLL is the energy drawn by its components, including the VCO, phase detector, and charge stop, which is crucial for power-sensitive applications. So the trade-off between these were the major task in PLL's IP designs. We also focused on advancements from CMOS to FinFET technologies. We also analyzed the emerging trends and challenges in integrating PLL into high-frequency SoCs. The key insights and trends. Transition from CMOS to FinFET nodes reduced power consumption and the chip area. Fractional and millimeter wave architecture enhanced the stability and the tuning range. Increased complexity introduced challenges in designs and manufacturability. Advanced design achieves noise separation crucial for high-frequency applications. Comparative analysis. Phase noise improved from -71 dBc per Hertz to -253.7 dB per Hertz in modern designs. Lock time was reduced significantly, achieving sub-200 nanoseconds in advanced architectures. The FinFET-based PLL exhibit higher power efficiency compared to the CMOS architecture. There was a trade-off in smaller nodes as we increase the variability and noise requiring innovative loop filters. It requires innovative loop filters. The challenges that we faced during our survey were designing ultra-low power PLLs while maintaining performance metrics, mitigating phase noise at higher frequencies and advanced technologies, reducing transistor counts to minimize chip area for SoC integration, ensuring design robustness against supply variations and thermal effects. The future directions. These were the scope for the new survey, a new research area. Focus on sub-20 nanometer technology nodes to enhance the integration and reduce the power. We also can develop robust PLLs to address noise and thermal issues in high-frequency systems as well as power consumption critical applications. Explore novel architectures like injection, locked, and adaptive PLLs. We can also use AI/ML for PLL optimization to balance the trade-offs in power, phase, and stability of the IC. Here, I conclude my presentation using the conclusion points. PLL design advancements are critical for modern communication systems. Innovations like FinFET nodes and fractional NPLLs improve performance and adds the complexity. Continued research is essential to overcome the challenges in noise, power, and stability. Okay, thank you. If there are any questions, I will like to answer them.
Thank you, Vaishnavi. Ma'am, do you have any question for this presentation?
Vaishnavi, very nice. My question is, in what ways might the development of AI and machine learning techniques improve PLL design and optimization in this future? Am I audible, Vaishnavi? In what ways might the development of AI and machine learning techniques improve PLL design and
Yes, ma'am, you're audible.
in the future?
Okay, so PLL designs have many complexities and trade-offs, as I mentioned, that there are, as we increase the power consumption, as we increase the size of the area, more high frequency PLL ICs, then there will be more power consumption. Then AI/ML would help in the design optimization techniques, like there would be some parameter tuning in VCO or the gain of the gain of the IC or the jitter and lock time would be improved. There would be certain adaptive PLL designs that would help me to adjust the real-time adjustment, like ML models can be used in adjusting the parameters. Example, the loop filter coefficients would be improved. Then, in response to these conditions, the uh, supply voltages and the temperature variations, the load variations can be controlled. Design
Excellent.
automation for layout would also be improved.
Very good. Excellent. Okay. Thank
Thank
you.
you. Yes, thank you.
Thank you,
Yes, sir.
Vaishnavi. Yes, ma'am.
Thank you.
Thank you. So next we have Vedant Khanpura, and he's going to present on adaptive diagnosing for enhanced image quality using modified unit. Vedant, you may please proceed with your presentation.
My screen is visible, sir.
Yes, it is visible.
Okay. Good morning, everyone. My name is Vedant Khanapra from Charusar University. Today, I will be presenting my research work on satellite image noise reduction, especially on modified unit architecture. My method enhance image quality while preventing crucial noise, which essential for the accurate analysis. And this approach is particularly valuable for the applications of environmental monitoring, disaster management, urban planning, and agricultural, where image quality of satellite is plays a crucial role in reliable insights. So first of all, problem identification. When I was exploring this field, I got to know that um, satellite image suffers from various defects like environment and technical difficulties, especially image with salt paper noise. Salt paper noise refers to pixel transferring into white or black randomly. So I found out that salt paper noise should be reduced in satellite image. So I have created a unit model for that with MSC and SSIM lost function. And key result was measured in PSNR metrics so that we can enhance the quality of image. Important of clear satellite image. As I said before, urban planning, we should know that clear boundaries with satellite image and disaster management also accurate image are crucial for efficient emergency response coordinate. And if we talk about agriculture, detailed satellite image supposed to precious farming and crop monitoring. So I have used modified unit architecture. If we talk about literature review, traditional methods like median filtering struggles with the complex noise pattern, and PSNR metrics of that methods are also less value. If we talk about, I also explore advanced models like evaluate filtering, fluffy logic, and RQ unit model. But they model improves high efficient and also gives high efficient result. But limitations of that model are overfitting and complex computation. While unit model keeps place between somewhere traditional method and advanced models. So I have implemented unit model and modify it. Its key contribution, as I said before, improve unit framework where I have normalized the batch normalization and stable training. Also, I have used dropout layers to prevent overfitting and combine MSE and SSIM loss function for optimal result. And I have also focused on denoise image sharpening so that we can clearly see the different aspects of image like structure and boundaries for the crucial detail to analysis more. So methodology is basically dataset pre-processing. First of all, I didn't find any dataset which is noisy with salt paper noise. So I have created my own dataset with Sentinel-2 European satellite and add on artifact of salt paper noise, and then modern architecture like I have created a unit model with base normalization and drop down layer, as I said before. Then I training the model with loss custom loss function, MSE and SSIM. Then pre-processing includes the unsharpened masking for enhancing the sharpness of image. Architecture is basically simple. Unit model structure like utilize the convolution layer, makes pooling and upsampling, and skip connection, which is very crucial for spectacle details during image reconstruction. And if we talk about the result, then this table says that if we add 5% noise in our satellite image, then our model is giving PSNR value between 25 to 26.5. Then if we denoise that image, then PSNR value increases like 14 to 41. Then if we sharpen our image by unsharpened masking, then 41.5 to 42.5 is giving range. And so on 10%, 20%, and 30%. If we add this type of noise, then we can achieve denoise image as sharp as 18 to 20 range of noise. Then if we get sharpened image like 39.5 to 41 in range, and so on. So this is the significant improvement in PSNR and SSMI value by this modified unit architecture and unsharpened masking. If we talk about analysis, then in the second image, we can see the comparison of image quality metrics across the different noise. Last blue line is of a noisy image, then a sharpen image, and denoise image. So basically, I didn't focus on uh, numerical values of PSNR evolution metrics, but I focused on visual clarity of satellite image. And I have faced some challenges like artifacts prevention and model generalization. Also, computational limitation, like such a big data set of these Sentinel-1 2 images was hard to manage and compute. And model generalization. As I said before, this Sentinel-2 image satellite is a European satellite. So my model was trained on European areas. So I have to generalize this model for all around area of the world. And real-time processing, uh, first this model taking time to train and giving image around 45 minutes or around. Then I have modified and fine-tuned the model for fast denoising and real-time sensitive. The roadmap ahead, I would like to extend my research by learning and implementing the hybrid methods like velvet and fluffy logic. And also, I would like to add a more parameter optimization for fine-tune the model and unsharp masking parameter to sharp the image in better way. So conclusion is I have choose the unit model because it plays some between the traditional approach and advanced model. So I can use this model to prevent some defects and generalize the satellite image noise reduction and enhance the quality of image by pre-processing and using the unsharpened masking. Real world impact, we can show that our model is now some of the website are using our model to prevent the satellite image noise and especially salt and pepper noise. Thank you so much. Is there any question?
This is meticulous presentation, very good. My question is, were there any qualitative results that particularly stood out in terms of how the model improved image quality? Should I repeat
Yes,
that?
ma'am.
Yeah.
Yeah. Mm, Basically, when I was searching about this field and salt pepper noise, so unit model was giving us the result of PSNR value like 39, 38, or somewhere between. But my model is giving value of 41. Sometimes is if the image quality is high, then 44 we can get the value of PSNR. And visual clarity, I basically focus on more visual clarity. So my image is more visual so that we can analyze it more.
Okay, that's good. That was good. It was
Okay,
meticulous.
thank you, ma'am.
Thank you. Okay. Over to you, Harsh.
Yes, ma'am. Okay, so next presenter we have Chandan Kumar, and he's going to present on an overview of cloud computing and the Internet of Things in healthcare.
Yes, I am audible, sir.
Yes, Chandan, you are audible. Please go ahead.
Good morning. Good morning to all respected panel members. I am Chandan Kumar. I am a BCA third year student at a School of Applied Science, and I shall be presenting my research work at this conference today. The conference ninth International Conference on Information and Communication Technology for Competitive Strategy ICTCS 2024. Then my paper ID 401. Then my paper title An Overview of Cloud Computing and the Internet of Things IoT in Healthcare. My research guide Dr. Shailesh Gane sir from Datta Mega Institute of Higher Education and Research, School Savangi Megawardha. Then this slide show content, introduction, research background, literature survey, summary of research gap, objective of the study, technology and architecture, current application of cloud computing, IoT in healthcare, future direction, then conclusion, then reference. This slide show introduction. The next paradigm shift is the Internet of Things (IoT), whereby sensors connect to the network and collect data for analysis, so that instrumentation, connectivity, and intelligent building and living and enhance. The Internet of Things (IoT) enables network sensors to collect and analyze data, enhancing a smart living and connectivity in a world increasingly reliant on mobile devices. IoT and wireless technology enable real-time health monitoring and data sharing with courageous transforming healthcare delivery. This paper explores various IoT and cloud applications in healthcare and highlight recent advancement in the field. The next slide, research background. Cloud computing and the Internet of Things (IoT) revolution in healthcare have enabled real-time monitoring, collection, and analysis of data from a connected device. Cloud computing and IoT revolution healthcare with real-time data monitoring and analysis from connected device. IoT and cloud improve healthcare with telemedicine, remote monitoring, and smart hospitals. Blockchain, 5G, and AI boost security, scalability, and performance. Then this slide show literature survey. I have mentioned 4 paper in literature survey. According to this paper, the role of Internet of Things IoT in healthcare. This work highlight how IoT connected device in healthcare to efficiently collect and share data. Vital for modern healthcare, it enables personalized real-time care, improving patient experience with timely treatments and intervention. According to this paper, Internet of Things and Smart Computing Revolution Healthcare. Wearable technology, IoT, and device collect vast amount of health data, enabling continued patient monitoring and timely medical in intervention. According to this paper, a study on healthcare security system integrated Internet of Things. Then this slide shows summary of research gap. The technology despite this still has significant gaps in interoperability across various IoT devices and cloud platforms. IoT device and cloud platforms in healthcare face challenges in interoperability due to different communication protocols and data formats, making seamless data sharing difficult. Standardization these systems is circle for realizing the full potential of IoT and cloud technology in the healthcare. This slide shows objective of the study. The first objective, discuss how cloud computing transforms IoT in healthcare. Then second objective, analyzing real-time solution like remote monitoring, telemedicine, and a smart hospital. Then third objective, examining challenges related to security, scalability, and interoperability with emerging technology like blockchain and 5G, etc. Then this slide show technology and architecture. The first diagram show IoT framework. IoT framework, for example, a wearable device monitors the vital of patient and framework forwards them to the cloud platform of the hospital so that real-time monitoring can be done. Then second diagram show cloud computing architecture. Cloud computing architecture, there are different types of cloud infrastructure in which healthcare system can be deployed, such as public cloud, private clouds, and hybrid clouds. Infrastructure provide a scalable capability for large pools of resource and offer cost efficiency. However, private cloud often share the same security controls. Then this slide show current application. The first application, telemedicine and remote patient monitoring. Then second application, a smart hospital and healthcare system. Then third application, wearable health device. This slide shows challenges in IoT. I have mentioned four challenges. The first challenge, data privacy and security. In IoT cloud healthcare, patient data is at risk of breaches, unauthorized access, or cyber attacks, causing privacy, financial, and legal issues. Then second challenge is interoperability and standardization. IoT devices with different protocols and formats face communication issues with cloud platforms completing healthcare data management. Then third challenge is network latency and scalability. Network delays and scalability issue can distort IoT cloud data flow, affecting remote monitoring and telemedicine. Then four challenges, power consumption and device lifespan. Healthcare IoT device need efficient energy use, continue data transmission, drains battery life. Then this slide show future direction. I have mentioned three future direction. The first future direction, 5G network. 5G network. 5G will enhance IoT cloud healthcare system by enabling faster, low latency data transmission, circle for real-time application like remote patient monitoring, telemedicine, and emergency care. Then second future direction, blockchain. Blockchain ensure the security, privacy, and integrity of healthcare data in IoT cloud system by using a tamper-proof ledger, preventing unauthorized access and data breaches. Then third future direction, artificial intelligence. AI, IoT and cloud computing together enable predictive analytics and personalized diagnostics, leveraging IoT data to identify patterns and predict health conditions. Then conclusion. In this paper, IoT and cloud computing in healthcare are discussed in relation to their transformative power in patient care. Patient may be monitored in real time by IoT device. Further, together cloud computing data may be stored and analyzed on large scale. However, such a solution still face issues related to security and privacy, along with interoperability. Future study must strive to leverage novel technologies such as 5G, blockchain, and AI for the effective handling of such issue and maintaining more innovation in healthcare. Then reference, I have referred total papers 26. Then thank you.
Yeah, it was a nice presentation. My
Thank you,
question
ma'am.
is, you mentioned blockchain as a potential for improving security. So could you explain how blockchain could be effectively used in this context and what its limitations might be?
Okay, ma'am. Uh,
Should I repeat my question?
yes, ma'am. Blockchain ensure the security, privacy, and integrity of healthcare data in IoT cloud systems by using a decentralized tamper-proof ledger, preventing unauthorized access and data breaches.
Okay. Okay, good. Over to you, Harsh.
Yes, ma'am. Okay, so next we have Bhagyashree Thakur, and she's going to presenting on assessing the impact of 5G technology on business operations. Bhagyashree, you may please proceed with your presentation.
Good morning to all respected panel members. I am Bhagyashree Thakur. I am MBA third semester student at School of Allied Sciences, DMA HCR, and I shall be presenting my research work at this conference today The conference name is the 19th International Conference on Information and Communication Technology for Competitive Strategies, ICTS 2024. My paper ID is 402. The title of my paper is Assessing the Impact of 5G Technology and on Business Operation. My research guide is Dr. Shailesh Gane sir from Datta Megi Institute of Higher Education and Research. The following slide that display all my study papers contain. First slide is contain introduction, research background, research gap, need of study, objective of research, research fact finding, conclusion, reference. First slide is introduction. 5G technology with data rates up to 100 times faster than 5G, lowest latency, device capacity, transfer industries by enable faster, reliable connectivity. Remote monitoring and predictive maintenance in manufacturing along with real-time chain tracking, improve machinery utilization and ensure smoother operation. Retailer leverage 5G for personalized customer interaction through AR commerce, while healthcare providers benefit for telemedicine, remote consultation, real-time patient monitoring. 5G supports that development of smarter cities, self-driving vehicle, AI-driven logistics, and smart grids, enabling real-time decision-making, cost reduction, and sustainable resource management. By enhancing communication for remote work and cloud services, 5G foster innovation and adoption of emerging technologies like AI, machine learning, and big data analytics. Next slide is review of literature, architecture by emerging technologies. This finding is the study identifies 5G capability to enhance data handling, support seamlines IoT integration, and ensure reliable connectivity. Five and Impact of 5G on digital transformation in business operation. This study identifies 5G accelerate digital transformation in industry like retail, finance, and manufacturing by facilitating AI, machine learning, and IoT for automation and faster process. Next is the role of 5G in smart manufacturing review. 5G enable smart manufacturing by supporting intelligent factories, supply chain automation, predictive maintenance, and automated quality control. It highlights 5G role in enhancing operational decision making through ultra reliable, low latency communication. Next finding is 5G and its impact of supply chain optimization. 5G enhance supply chain optimization by improving real-time tracking, monitoring, and data integration in logistics. It leads to better demand forecasting, inventory control, and faster decision making. Next is 5G technology, a strategic driver for business innovation. This finding is 5G serves as a strategic enabler of business innovation, empowering renew growth, enhance consumer engagement, and improve customer experience through advanced technologies like AR and VR. The research gap is limited research. Explore the effect of 5G when combine AI and IoT multi-domain ecosystem, such as cross-sectorial application in include manufacturing, finance, and healthcare. There is a lack of studies addressing the environmental application of 5G regarding energy consumption and its alignment with sustainability goals alongside of between enhanced business efficiencies and increased demand. Objective of the research to explain how the integration of 5G and AI, blockchain, and IoT is driving innovation industry. To explore the environmental application of the spread of 5G infrastructure, energy consumption, and sustainability issues. To design prediction model to evaluate the scalability, sustainability, as well as hazards to constraint that might arise once 5G becomes truly operational. The research fact finding is the image provides table outlining the evaluation of mobile network generation 1G to 5G, highlighting their keys of advancement. Next is 1G. 1G finding is 1984 2.5 2 kbps basic voice service analog base And 2G fine is 1919 64 kbps designed for voice digital standards. 3G fine 1998 to 2 Mbps voice and data mobile broadband. 4G is 2011 100 Mbps IP-based protocols through mobile broadband. 5G is 19 to 2019 10 Gbps low latency fast speed. Conclusion is the convergence of 5G with AI, blockchain, and IoT unlocks innovative connectivity such as real-time data analytics, automation, and secure decentralization system integration drives significant opportunity for advancement across drivers, including manufacturing, healthcare, and smart city development. 5G enable technologies such as IoT for real-time monitoring and AI predictable and blockchain for secure data transmission are set to revolutionary operational support a new business model and enhance user experience across sectorial. Long-term research is essential to track the evolution of 5G enabled technology, sustain impact on business operation, and the challenges of widespread ensuring informed strategic for leveraging 5G's full potential. References is I have referred total papers 26. Thank you.
Yeah, excellent presentation. Okay, my question is, you mentioned the coverage of 5G, AI, and blockchain and IoT. So, can you elaborate on how these techniques work together? Why did you choose these four techniques? I mean, how you integrate that? So, how these techniques work together in practice across sectors like healthcare, manufacturing, and finance? Bhagyashri?
Ma'am, repeat the question.
Okay, repeat it. So you mentioned the convergence of 5G, AI, blockchain, and IoT. Can you elaborate on how these techniques work together in practice across sectors like healthcare, manufacturing, and finance? So why did you choose these techniques? Why? Or how do they incorporate? And what are the challenges in ensuring their, integration? What challenges you faced when you integrate these five techniques? Okay, no problem. I just want to give you one suggestion. If it would be beneficial if you include specific examples or case studies of businesses, especially SMEs, that have successfully integrated 5G, AI, blockchain, and IoT techniques. So this would help the audience also, so for better understand how these techniques have been applied in practice. Okay, Bhagyashri.
Yes, ma'am.
Okay, over to
Thank
you,
you.
Harsh.
Yes, ma'am. Yes, so I'd like to invite the next presenter. Next, we have Reva Satape, and she's going to present on decoding deepfake audio with machine learning, a comprehensive review. Reva, you may please proceed with your presentation. Not an issue, no one is available from this paper title. So we'll move forward for the next paper. Next, we have Arya Kapse, and she's going to present on enhancing child patient management and evolution of cloud-based solutions for streamlining patient histories, appointment scheduling, and vaccination notification. Arya, you may please proceed with the presentation.
Yes, sir. It is visible.
Yes, it is visible.
Okay. Good morning, respected panel members. Uh, my name is Arya Kapse, and I am presenting my paper in ninth International Conference on Information and Communication Technology for Competitive Strategy (ICTCS 2024). My paper ID is 397. My paper title is Enhancing Child Patient Management and Evolution of Cloud-based solution for streamlining patient histories, appointments, scheduling, and vaccination notification. I am the student of Dattamegi University of Higher Education and Research with my guide Dr. Shailesh Gahane sir and my other co-authors Shraddha Modure and Ekta Raut. The content we are going to cover in this presentation is introduction, research background, literature review, research gap, objective of research, research methodology, conclusion and reference. Then we have introduction. This system ensures fast access to critical child health care during emergency, enabling timely, effective medical care. They support real-time monitoring of chronic condition, allowing doctor to track patients continuously and ensure appropriate treatment. Families gain peace knowing that their child is getting tracked by a good doctor. And additionally, this system promote proactive health management by providing automated alert for vaccination and preventive screening, helping prevent audible diseases. Then we have research background. Traditionally, healthcare system often face inefficiency, especially in emergency, due to the unavailability of critical patient data. Immediate access to the child medical history, allergy, and current treatment significantly improves outcome, particularly in critical and chronic care scenario. Continuously monitoring for child with chronic condition is challenging. Require real-time data and collaboration with family. Cloud-based healthcare system address this need by enabling details, health tracking, timely treatment adjustment, and enhanced communication. Then I referred some papers are mentioned here in literature review. Enhance patient engagement through cloud-based notification system, a perspective, Journal of Pediatric Healthcare Technology, which tells some finding. Notification system enhance pediatric care by improving patient engagement through time reminder. And the remark we have attempt investigate how cloud-based notification system can work toward improving patient engagement. Then I referred next paper, cloud-based electronic health records in pediatric care, enhancing accessibility and data security, Journal of Healthcare Information, which tells some finding electronic health record improve accessibility and data security in pediatric care by enabling real-time access to patient information. With remark highlight the advancement of cloud-based electronic health record. Then third paper I referred, cloud computing and patient-centered care, benefits for pediatric healthcare system, International Journal of Health Information Technology, which tells us cloud computing enhance patient-centered care in pediatric healthcare by enabling personalized real-time access to the patient data. With the remark explored how cloud computing can support the improvement of patient-centered care for pediatric healthcare system. Then we have data security in cloud-based EHR platform for pediatric patient, a critical review journal of cybersecurity in healthcare. With finding cloud-based EHR platform for pediatric patient with remark whilst cloud a critical review of data security measures in cloud-based EHR platform. Then we have evaluating the performance of cloud-based healthcare system using machine learning techniques, IEEE Journal of Biomedical and Health Information. The paper evaluate the performance of cloud-based healthcare system by applying machine learning. Then we have remark access the performance of cloud-based healthcare system using machine learning approach. Then the research gap we get from this literature review that the use of cloud-based solutions in pediatric healthcare has shown benefits in improving care, coordination, and patient engagement, but there are notable gaps in research. Challenges such as need for training, change management, and long-term impact on chronic condition care remark under studies. Additionally, there is limited research on how machine learning can enhance cloud-based system for predictive analytics and treatment plans. Then we have objective of my research paper. The first objective is to build a system where emergency information pertain to child patient is accessed quickly by practitioners. Then next objective is to feature implementation that enable telehealth service to remote management and monitoring of chronic condition so the child healthcare provider may observe the patient's progression. Then we have a third objective to streamline administrative tasks such as scheduling and communication with the patient through a central platform in the cloud. Then we have fourth objective of my paper is to feature in development will include stimulating proactive child health management, reminding patients of time for vaccination, time for health checkup. Then research methodology, covered one diagram in it that the system is designed with the need assessment. We collect some data from the patient's history or treatment he is taking. Then we provide security measures to that system that the assessment we need. We will provide some security, then adopt prevention, and then development of the system is occurred. Then the feature optimization in which the maintenance of the secure data is happen. Then we have research workflow in which we covered some steps. The first step is start, then we collect the need assessments, then technology selection in which the data and technology is selected, then security measure, the data we are collecting, we need to provide some security, then development of the system is created, then integration and healthcare system. In that system, we will integrate the healthcare system then provide reminder and alerts, testing and quality assurance, training and testing, monitoring evolution and support maintenance aims. Then we have conclusion. The purpose e-health information system aim to enhance practical healthcare by improving the speed and effectiveness of medical interventions, especially in emergency. It features real-time monitoring for chronic condition, enabling timely adjustment to treatment. This system optimizes administrative tasks like appointment, scheduling, patient communication, relieving healthcare providers of some of their workload. Additionally, we get feedback from the patients and train other patients too. Total reference I referred here 26 research paper and thank you.
Okay, it was meticulous presentation, yes. My question is, what are the next steps for the system in terms of research, development, and deployment? Future scope. What are the next steps for the system in terms of research, development, and deployment?
Ma'am, will you repeat question?
Yeah, yeah.
You are not audible.
Okay, now am I audible? Now am I
Yes,
audible? Yes. Okay. So my question
yes.
is, what are the next steps for this system in terms of research, development, and deployment?
Okay, so when I means I am ready to prepare one project on this system, and next step is to take that collect data from the different hospitals of child care, and I will take one survey on it and provide some data to my system that it will informative to me as well as my system, and it will provide proper treatment to our patients and also the families survey will taken on it.
Okay, the
Yes,
data which you collect, is it qualitative or quantitative? What do you think? The data which you collect, is that qualitative or quantitative?
qualitative.
Qualitative. Okay,
Yes,
good.
thank you, ma'am.
Over to you, Harsh.
Yes, ma'am. Okay, so next we have with us Nitin Dattu Thorve, and he's going to present on hyperscaler driven IoT in drip irrigation, optimizing water use and crop productivity with advanced analytics. You may please proceed with your presentation. Is there anyone who's going to present this paper on behalf of Nitin? All right, not an issue. We'll move forward. Next we have Shraddha Mahadure, and she is going to present on impact of network latency on load balancing in cloud gaming systems. Shraddha, you may please proceed with your presentation.
Yes, sir. Good morning, everyone, respected panel member. I am Shraddha Mohdure, representing 9th International Conference on Information and Communication Technology for Competitive Strategy ICTCS 2024. The paper ID is 398, and the title of the research is Impact of Network Latency on Load Balancing in Cloud Gaming System. I'm studying in Datta Meghe Institute of Higher Education and Research, School of Allied Science, Savangi Meghe, Wardha, Maharashtra. The research I am the research author, Shraddha Modre, and my co-research author is Shailesh Gahane, Pankaj Anavde sir, Ekta Raut, Arya Kapse, Chandan Kumar, and Pranjal Bhute. I am going to cover in this presentation. First one, we can discuss about introduction, research background, research gap, objective of research fact finding, conclusion, and reference. The introduction, this is the introduction slide. We can cover about cloud gaming allow a player to access a video game on remote server without requiring high-end hardware, reshaping and gaming land space. Network latency critically impact the gameplay, especially in fast space or real-time games. Efficient load balancing is crucial to allocate the resource, manage the traffic, but it latency can disturb its effectiveness. High demand events such as a game launch or tournament, the leading the server crash, degraded quality or long wait time. Then we are cover. I have mentioned four literature review. First one is a dynamic load balancing in cloud gaming using a machine learning. This paper presents the dynamic load balancing model for cloud gaming using a machine learning, focusing on minimizing the latency and optimizing the resource allocation. The paper aimed to design a real-time dynamic load balancing model for cloud gaming system. It improved the user experience during the high traffic movement. The second literature I have mentioned that is a latency aware cloud gaming load balancing model based neural network general of cloud computing. This paper propose a neural network based load balancing model for cloud gaming. The aim idea of the study building a model that utilizes the neural network for load balancing on cloud gaming. The predicting the latency that greatly improve the overall performance of a cloud gaming system. The third one, research literature review, that are the scalar load balancing algorithm for latency reduction in large-scale cloud gaming event, general to parallel and distributed computing. This paper are introduced the scalar load balancing algorithm designed to reduce the latency during the large-scale cloud gaming event. The scope of the study designed the scalable algorithm for load balancing that specially a trailer for the reducing the latency in large-scale cloud gaming event. Also is boosting server load during the peak traffic on cloud gaming. The fourth one, literature review are latency aware load balancing in cloud gaming, a performance analysis. This paper analyzed the performance of latency aware load balancing technique in cloud gaming, focusing on optimizing the resource distribution of reduced latency. The purpose of study, several analyses of evaluate the latency aware load balancing strategy in the context of load cloud gaming to improve the game performance. Improvement in the gaming performance even when the network is subject to the fluctuation. Now we discuss about the research gap in these four literature review. The current research on latency aware load balancing in cloud gaming has mainly focused on fixed machine learning method, which could enhance the adaptability and effectiveness of cloud balancing algorithm. There is a lack of imperial testing in the real world gaming scenario. With the many study relying on the stimulate network condition. Additionally, the potential integration of edge computing with the existing cloud infrastructure remaining the underexplored, and the current algorithm are often too computationally intensive for smaller gaming provider. Now, these are the suggested steps for load balancing control. First, first step of the this diagram is latency data collection. Then second, we can analyze the data. Then latency aware load balancing model. Test scenario in control environment. Identify the user experience matrix. Design stimulate experience. Evaluate the network performance versus users satisfaction. Evaluate the machine learning techniques. Incorporate energy efficiency matrix. And last one is integrate the security consideration. Now the objective of research. The objective of this study is a focus on different parameter of uh, cloud gaming load balancing concept. First one objective is to analyze the network latency effect and develop a latency aware load balancing model. Second objective is to access the user experience matrix and conduct a stimulation experience experiment. Third objective to explore the diverse machine learning technique and focus on energy efficiency and security. The this paper conclusion are the research propose a model to improve the cloud gaming performance by reducing the lag and balancing the server load more effectively. And second one, it can suggested using reinforcement learning to predict and manage the latency, ensure smoother gameplay, especially in multiplayer games. The paper also highlight the need for a energy efficient algorithm to cut operating cost and support sustainability. And the last thing is, additionally, it traces the importance of using um, encryption to protect user data and keep the gaming system secure. There are some 24 references I mentioned. First one is a dynamic load balancing, network latency resource optimization, uh, latency aware cloud gaming, and fourth one is edges computing for cloud gaming. Thank you.
Okay, very good presentation. Okay, my question is, am I audible? Yes, am I audible to you?
Yes, ma'am.
Okay, so what were the primary limitations of this study and how do you plan to address them in future research? What were the primary limitations of the study and how do you plan to address them in future research?
Primary objective is we can
Primary limitations. What was challenges you faced in this? What were the primary limitations and how do you plan to address them in future?
the first primary limitation is a single point of failure. When we are using the any gameplay, there are a failure of networking and all. They can be overcome by this. And second is the complexity and scalability issues, then cost, health check overhead, and state management, uneven traffic distribution, limited application, and so on, ma'am.
Okay. So how do you plan to address them in future research?
Um, if non as a climate system become a more traced by global warming, load behavior and feedback mechanism may be harder to predict, but new feedback such those related to extreme weather or steep point cloud complicated methods.
Okay. Okay, that's it. Yes, over to you, Harsh.
Yes, ma'am. Okay, so next presenter we have is Lily Gohai Barwa, and she's going to present on multi-class classification of LC computed tomography images using transfer learning based on ResNet 50. Dear presenter, you may please proceed with your presentation.
Good morning, everyone, and dear ma'am, good morning, everyone. So myself is Dr. Hilimohai Burwa. I am currently working as an assistant professor in the Department of Advanced Computer Science and Engineering, and these are all my authors, co-authors. Actually, this is the work done by my BTech project students, outgoing project students, and they couldn't present it today, so I am presenting on behalf of them. And the title of our work is Multi-Class Classification of Lung Cancer Computed Tomography Images Using Transfer Learning Methods Based on ResNet 50. So as we all of us know that, wait ma'am, it's not going. Okay, so this is my plan of talk. I'm going to give a brief introduction about the work and what we have done and what results we got and what conclusions we got after completion of the work and references that we have used. And as all of us know that lung cancer is a deadly disease. Actually, cancer is a deadly disease, and out of that, lung cancer is considered to be the deadliest disease. And lung cancer is of different types. And what we say that up to 40% of 40% of lung cancer is adenosarcoma, and after that 10% is large scale sarcoma. After that 30% is squamous cell sarcoma. Until now, lots of works has been done based on to classify the lung cancer images. And in many of the work, they have just found out whether the lung cancer is present or not. But with our approach, we are trying to detect the presence of cancer, lung cancer, as well as to classify in different categories. And we can overcome, see, I already told that there are different types of works that has been already done in conventional approaches as well as machine learning and deep learning algorithms also. So we are trying to add a simple drop in that work by utilizing ResNet 50 for our transfer learning. And we all know that till now many works has been done, and CNN is the most popular model till now. But CNN also has some drawback because CNN's performance deteriorates based on in the absence of large data set. So we have utilized the transfer learning method to get over this restriction by using the pre-trained neural network, and this model is enhanced using a fresh data set. And what we do with the help of pre-trained neural network, either we modify some of the pre-trained models layers, or we add some more layers in that layers. And here we have tried to develop one lung cancer classification model based on transfer learning, which is based on the pre-trained CNN convolutional neural network architecture, that is ResNet 50. And we have also found out the performance comparison with other transfer learning models based on EfficientNet B4 and DenseNet 201. And this is the block diagram of overall proposed methodology, what we do actually for lung cancer classification. We have the data set and we load the data set. After that, we pre-process it. And in our case, we have pre-processed it by images doing the resizing it up to 255 into 255 into 3. After that, we get the pre-processed data, and that with the help of the pre-processed data, we train the model. After that, we test it to get whether our training is going well or not. We test it. Okay. So next comes, this is the overall actually what we have done in ResNet 50. There are multiple layers, and we have modified the last layers by adding average pooling layer and dropout layer and softmax activation function to classify into different classes. And the data set that we have used, actually they have 4 types of images there. 3 types of lung cancer images, as well as one is image without any cancerous cell, that is normal cell. And data set that we have used, we have considered it from Kaggle. And that data set, this is the sample images. The first image is of adenosarcoma. Second image is of large cell sarcoma. Third cell is of squamous cell sarcoma. And these are the normal images. And dataset already I have mentioned that it consists of 100 CT scan images, and the images that ratio that we have used for training, testing, and validation are 70%, 20%, 10% respectively. That's how the number of images become 613, 315, and 72. So I already mentioned in many works has considered different models, and they have tried to detect the presence of lung cancer. So with the help of only 1,000 CT scan images, that is label data that we have, we are utilizing transfer learning to detect the presence of or we are trying to find out or classifying the lung cancer types. And for that, we have used the experimental configuration as such. And we have used TensorFlow as the backend, and we have used Python programming language as well as the Keras library with Tesla T4 GPU with 25 GB of RAM. And we have done the experiment with Google Colab Pro Computer. And main thing, we also know that when we work with convolutional neural networks or pre-trained models, the hyperparameters play a very important role. So with empirical experimentations, we have found out which setting is best according to for our dataset, and we have found out we have calibrated the batch size, optimizers, learning rate, epochs, as well as loss function for lung cancer classification. And we have also found out that weights of dropout layer and patients in early was changed during hyperparameter. And we have also changed dropout layers from 40% to 60%, patients from 15 to 20, and then epochs from 100 to 20. The optimizer that we have considered is Adam optimizer. See, we have done experiment with other optimizers also, but we found Adam optimizer to be the best one for the experiment. And the activation function that we have used is softmax. And these are the results that we got. And we have done the experiment with ResNet 50 as well as EfficientNet B4 as well as DenseNet 201. And if you see that before hypertuning, the EfficientNet B4 was giving more accurate results. But when we did the hypertuning, ResNet 50, though it is little bit, we can say little bit inferior compared to EfficientNet, after hypertuning, it is getting good results. It is getting an accuracy almost up to 91.87. So it says from the study, we can also see that the hypertuning really affects in increasing the accuracy if we do it properly. And this is we are displaying the confusion matrix as well as the curve for training accuracy validation. And if we see observe B, we can see that as the number of epochs is increasing, we are also getting good accuracy. So in a gist, if you can tell, we have used ResNet 50, the EfficientNet B4 and DenseNet 201 for transfer learning. And out of those, we have found out that without hypertuning, EfficientNet B4 works the best. And after hypertuning, ResNet 50 is working fine, and it is giving accuracy of up to 91.87. And why transfer learning? We considered that transfer learning, I already mentioned that transfer learning works well with images, but especially in medical field, because in medical field, we cannot get much properly labeled data and in a large amount. So that's why transfer learning can be a very good, effective tool for doing the experimentations for lung cancer classification. And in future scope, if we mention that this is actually our first experiments that we have done. So in future works, we are trying to work with more data sets, large data sets, as well as we want to create our own data set by using different constraints. And also we want to work not only with deep learning features, as well as we want to incorporate as well deep features as well as handcrafted features, because they both have different characteristics and they can give different information regarding the images. And these are some of the references that we have used. And in all maximum of the works, they have considered different deep learning models. They have considered transfer learning also. And we have found, and these are the references that we have used. And thank you. So if you have any questions, you can ask.
Thank you
Thank
so
you, ma'am.
much. This is quite an informative presentation. Thank you, ma'am. This is
Thank you,
a
ma'am.
captivating presentation. No questions from my side. Yes, over to you, Harsh.
Thank you, ma'am.
Thank you.
Yes, ma'am. Okay, just a second. I'll invite the next presenter. Next, we have Ekta Rao, and she is going to present on predictive maintenance of EV batteries using machine learning and cloud computing. Ekta, you may please proceed with your presentation.
Yes, sir.
Go.
Am I audible, sir?
Yes, you are audible.
Good morning, all and respected panel member. My name is Ekta, and I am presenting my paper in 9th International Conference on Information and Communication Technology for Competitive Strategies ICTCS 2020-24. Paper ID is 399, and the title of paper is Predictive Maintenance of EV Batteries Using Machine Learning and Cloud Computing. I am studying in Datta Megi Institute of Higher Education and Research, School of Allied Science, Savangi, Varda, Maharashtra. Ekta Roth, I mean, author, and my guide author is Shailesh Ghane sir, and co-author is Arya Kapse, Shraddha Mohdure, and Pranjal Bhute. The content is introduction, research background, literature survey, research gap and need of study, objective of research, research methodology, conclusion, and reference. The first is introduction. The whispered adoption of electric vehicle worldwide brought attention to the critical need for an effective battery management system, as the battery is probably one of the most expensive and crucial component in the electric vehicle. Predictive maintenance now, supported by the technologies like machine learning and cloud computing, hold out a promises of resolution to these challenges through productive data driven decision making. Predictive maintenance will have constant monitoring of a battery for a health and performance parameters such as voltage, current, temperature, and state of charge in order to predict when a failure is likely to occur. Although predictive maintenance of EV batteries has many apparent metrics, several interesting challenges arise in connection with it. This is the diagram of a training model for EV battery. The research background is the urgent requirement of preventing the generation of greenhouse gas emissions, along with the need for monitoring transportations, has back up the shift of the market to electric vehicles. The only significant challenge associated with EVs lithium-ion battery management, as it is vulnerable to several factors such as the temperature, charging cycle, and operating conditions. The solution to challenge is found in predictive maintenance, which anticipate and rectify potential problems before they become troublesome. The literature's review. The first is the first is robust state of charge emission estimation of LiFe PO4 batteries for EVs. The findings is introduce a state of charges estimation technique specially designed for LiFePO4, and the remark is the study tackles critical issues in SO estimation by addressing battery non-linearity and verifying conditions. The second is lithium ion battery management system for electric vehicles, constant challenges and recommendation batteries. The findings is um, focuses on the constraint and the challenges associated with lithium ion batteries management in electric vehicle, and the remark is the study of highlight critical challenges in battery management, particularly focusing on the practical issue of thermal control and the adverse effect of the rapid charging. The third is battery safety fault diagnosis from laboratory to real world. The findings is um, to improve battery safety by developing a technique in which fault diagnosis method would transmission from the laboratory to application use. The remark is The focus on this study is on diagnosis of the safety issue of a battery by utilizing advanced diagnosis and technique of machine learning. The fourth is battery technology and functionality of the battery management system of EVs, current status, key challenges, and future prospect. The findings is the findings in the review the status of battery technology and examining the performance challenges and future perspective of battery management system for electric vehicle. And the remark is the study provides a broad review of current and emerging battery technologies, making it valuable resource for understanding the developing landscape of BMS and EV battery systems. The fifth is general discharge voltage information enabled health evaluation for lithium ion batteries. The findings is a method for evaluating the health of lithium ion batteries using discharge voltage data. And the remark is the study introduce a practical and efficient method for battery health evaluation, focusing on uses of discharge voltage data, which is readily accessible in the most battery system. The next is a research gap. The literature about the estimation of SOC of EV and BMS numerous, which shows many advancement and challenges in the field. So it indicates various research gaps that need to be addressed to improve the efficiency and reliability of EVs. The research by on the estimation of SOC and LEFE-PO4 batteries is actually successful in presenting battery accuracy and robustness in the estimation model without being able to generalize to various battery chemistry and EV model. The computation complexities of the purpose model are quite high and practically used in the actual EV scenarios. In this study, several constraints in the BMS are identified, such as thermal management, inaccuracies in state estimation, and adverse effect of rapid charging on a battery lifespan. The objective of the research paper is first is to develop predictive model for battery health monitoring and enhance computational efficiency of SOC models. Then second is the to integrate cloud computing for data management and real-time data for predictive maintenance. The third is to conduct a comparative study on predictive maintenance strategy. This is research methodology. The first step is collecting and processing, then second is selection and engineering, then third train machine learning, then validation and testing, then optimizing computational efficiency, then a cloud infrastructure, then real time data processing pipeline, then deploy the predictive model, then comparative study, and then statistical test. The conclusion is research objective development of predictive model for battery health monitoring integration with the cloud computing data management comparative study on various predictive management strategies important finding the respective potential of machine learning and cloud technology allow an opportunity to improve efficiency and reliability in EV battery management system. Advance in a predictive model based on algorithm like SVM and ANN have proven to predict the battery health based on prediction of historical data such as charging pattern and those of discharging. The model, aside from increasing the computational efficiency, boosts the accuracy in estimate made in state of charges and state of health. I mentioned total 20 papers in 20 reference paper in this research paper. Thank you.
Thank you. My question is, you mention a significant reduction in the error of estimates when real-time data was incorporated. Am I audible? Am I audible to you?
Yes, ma'am.
Okay, so my question is, you mentioned a significant reduction in the error of estimates when real-time data was incorporated. Can you provide a specific metrics or examples of how much the error was reduced in terms of percentage or absolute value? Can you provide a specific metrics or example?
Yes, ma'am.
Yeah, how much the error was reduced in terms of this percentage? Should I
Uh,
repeat my question?
Yes,
I would like to ask, can you provide specific metrics or examples of how much the error was reduced in terms of percentage? You mentioned the significant reduction in the error of estimation was when real-time data was incorporated, right?
yes, ma'am. First is data collection and integration. Install in EV batteries continuously data collected on parameter like voltage, current, temperature, charge cycle, and then machine learning models, regression models, classification model, error handling, then error prediction and handling. In this predictive battery failure time, and then cloud computing for real time monitoring. There's remote monitoring and scalability.
Okay,
And
okay, okay. So how much the error was reduced in terms of percentage? Could you please tell me that? How much the error was reduced in terms of percentage?
ma'am, I'm working on it.
Okay,
Uh,
okay, okay. Okay, great, great. Okay, excellent.
Thank you, ma'am.
Over to you, Harsh.
Yes, ma'am. Just a quick announcement for those also who are not presented. Is Revas Sartape is here?
Yes, good morning, sir. Sorry, due to some technical issues, I couldn't present at the given time.
All right. Reva, you may please present your paper. Its paper title is Decoding Deepfake Audio with Machine Learning, a Comprehensive Review.
Yes.
You may please proceed.
Sir, is my screen visible?
Yes, it is visible.
Okay. Very good morning to everyone. Would like to present our paper, Decoding Deepfake Audio with Machine Learning. And along with me are my authors Shreya Kumar, Akhil Tomar, MB Munod, and RC Jaiswal. So, would like to actually start off with an example which took place in 2021, where criminals used AI generated voices to impersonate a CEO, successfully scamming a company out of around $2,043,000 on just a single phone call. So, this emerging threat, fueled by advancements in the AI voice synthesis, underscores the critical need for robust methods to detect and mitigate the deepfake audio. And herein where our projects come in to picture, that is the detection of deepfake audio. Now, what is deepfake audio? To say in simple words, it is something which has been the voice which has been generated by the AI that sounds remarkably similar to the real human voices. And why it is as a threat, as mentioned, security risks are there. There's a misinformation that can happen, along with some frauds and financial scams. So our objective being to present deepfake audio detection using CNN and LSTM models to improve accuracy in identifying the synthetic speeches. Along with that, we would like to highlight the integration of CNN for feature extractions and LSTM for temporal sequence learning and deepfake detection. Also to mention, we had discussed many challenges and future direction in our paper, which is regarding to how we will be detecting the deepfake and few of the challenges like to remove the noise in the voices. Our aim of the project is again to deepfake audio detection, which is to develop and evaluate methods or models that can effectively distinguish whether the input voice is it a human one or it is being AI generated. Now, deepfake audio is known to mimic real human speech, sometimes even replicating the specific individuals, can be used for many nefarious purposes. Our methodology includes 6 of the most important steps. First, starting off with the data collection. Now, it is very important when we are making a model to collect the data. So we'll be gathering the audio samples that are available out there, along with we are planning to create our own data set. Followed up by the process of pre-processing, which is mainly converting those collected audios into spectrograms. So these MEL frequency spectrograms will be consisting of the frequency versus time uh, graphs. And along with that, we are planning to have an imitation module just to develop and utilize a model that can simulate a real human voice with all the characteristics. And our model will be analyzing the key features, which is mainly the prosody or what are the emotional tones of the voice, And then comes the comparison, which is the most important, which will be comparing the two voices basing on the pitch. It can be prosody or some of the other dynamics. Now, here one important point comes in when it is the AI voices, those have a very less consistency as compared to the real human voice. So we'll be trying to work on that along with the machine learning classifiers. So here in the paper, we are planning to work on SVMs and CNN classifiers along with the explainable AI. And evaluation parameter would be including accuracy, precision, recall, and F1 score, etc. So a few of the software requirements are mentioned over here. So this is a basic mechanism of how the CNN or the SVM model will be working on taking a input, which will be the audio, followed up by segmenting it to two forms, which I said the spectrograms will be converting those audio into graphs. And then we'll be applying the classifiers, as you can see, the pre-trained models and the MLP, which will be giving us the output, whether it is a fake or a real one. Very simplified version, what we have tried to depict over here. The pre-processing followed by the training and the testing. So starting off with the SVM models. So here again, we'll be setting up few of the SVM parameters, training the model by finding out the optimal hyperplane that would separate the classes with the maximum margin. And it would identify the supporting vectors. Next is the CNN algorithm, which we will be using. We'll be applying a ReLU function used to like pool the layers down to sample the data, which will help us to reduce the dimensionality of the big data sets and the parameters in it. Next is the LRP algorithm. Next is again LSTM. And here comes the data set. Now, a few of the data sets available out there include LG speech, ASV spoof, deep fake, fake or real. And all these data sets come with their own advantages and disadvantages, starting off with what languages do they support and how much of the accuracies each of them provide. We are focusing more on the ASV spoof 2021 because it has got over accuracy of about 98% if I'm close to it. And along with that, the other data set, which is fake or real. So as mentioned, these are a few of the data sets which we will be, again, focusing on. And this is a comparison of all the data sets with their accuracy based on two of the classifiers. Those are CNN and SVM. So as we can see over here, we have got ASV spoof getting to around 85.9 and ARDAD having a good accuracy, but it has disadvantage being the entire data set is based on the Arabic language, which we can't implement in our model because we are aware that the language mostly spoken by the people in India is English or Hindi. So that's why we didn't go with the ARDAD. And our research had also involved going through the different algorithms available and their accuracy being mentioned over here. The SpecArnet giving about 99.93% of accuracy, along with that of CNN, 98%. So few of the evaluation parameter, as I mentioned earlier, would be recall and precision. So recall would be measuring the effectiveness of the model and identifying the instances like whether the output is it a true positive or a true negative. And the second one being the precision. So it would be a proportion of relevant instances out of the model that will be retrying. Followed up by the F1 measure, some weighted F measure, and mean absolute error. Another important parameter I'd like to mention is the equal error rate, which we will be again focusing on because different classifiers have their different equal error rate, which will be identifying whether the output is it a false negative, whether the model is able to predict the correct output as correct or it is proving it as a wrong. So this one would be an important thing to look out for. And few of the results which we are aiming to achieve would be the random forest classifier, which achieves an accuracy of 99.76%. We would be having the generalization limitations on that CNN and SVM model performs well in controlled environments, but they do face challenges with the real world audio. So one of the difference between CNN and SVM would be that CNN is kind of more stable because it has a similar performance regardless of the data set. But when it comes to SVM, those are a bit unstable because it performs differently depending on the data and the fakeness type. These are, again, the results which we will be trying to achieve. We are still working on it, so we haven't really achieved as mentioned results. A conclusion is to have a real world variability, that is to detect model facing challenges with the real world audio, along with the dataset diversity and the consistency we would try to achieve. And we have gone through around 19 research papers. Those are available on the internet. And this is how I'd like to conclude my presentation. Thank you so much.
That is captivating presentation. My question is, what role do you think policy and regulation should play in the development and deployment of deep fake detection technologies?
As in policy, should it be like implemented
Yeah,
by
yeah,
the
like role
government?
of policy and regulation should play in development and deployment of deep fake detection technologies.
So we all are aware that privacy comes into picture, and this is very important because we can't have a model that would be able to record each and every of the, say, the audio that will be given as an input from the user. So
Yeah.
I believe privacy is one of the challenges that we can face, or the policies can have a major contribution in.
Now, how do you balance the need for reliable detection with concerns around privacy and potential misuse of deepfake detection system?
You
So,
mean
how do you balance the need for reliable detection with concern around privacy and potential misuse of deepfake detection system? How do you
So,
balance that?
I believe we can give an option to the user that
Yeah.
if they are okay with, sharing their information just to make their system secure, then we will be okay with dealing with this. But yes, a few more research, or these are the points we will be working on.
Okay, Vidya. Great, great.
Thank you.
It was an amazing. Yes, over to you, Harsh.
Yes, ma'am. Just a quick announcement for Nitin. Is Nitin is available with us?
Sir, I'm sorry, can you please repeat?
The Nitin, the Tuthore. Okay, so I think so. Nitin is not available. So as we have completed all the presentations during this session, so we are moving forward for the closing the session. So I sincerely thank our authors for their great presentation and contribution in this during the session. Okay, just a second. Okay, I hope this session was informative enough to all the participants. We, on behalf of the whole team, thank you for your support during the ninth version and all previous 8 version of the conference. We will be happy to have you all in the 10th version in 2025 of this conference. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the stranger. The publication will be live within 6 to 7 months. So kindly cooperate with the team ICTCS 2024. I also thank our session chair for chairing the session. Just a second. Yes. Ma'am, there is a one token of appreciation to be a chair on behalf of team ICTCS and Global Knowledge Research Foundation and the partners.
Thank you.
Thank you, ma'am. Thank you for your valuable presence over here. Okay,
Okay, thank you.
so just
As we conclude this engaging session of ICTC 2024, I would like to extend my heartfelt appreciation to all the presenters for their insightful contributions and to the participants for active involvement. The diverse research presented here today highlights the innovation and collaboration within the global academic and industrial community. I am confident that the discussions we have had will serve as catalyst for future advancements in information and communication technology. Let us continue to foster connections and share knowledge to drive competitive strategies forward. Thank you, and I wish you all a productive continuation of the conference. Thank you so much. Thank you, everyone.
Thank you, ma'am. Sure, valuable.
Thank you so much,
Okay,
ma'am.
so
Thank you, sir.
just before end this session, I request you all to turn on your camera so we can capture the good memories of this virtual conference. Request everyone, if it is possible, you may please turn on your camera. Okay, yes, yeah.
Thank you.
Thanks a lot, everyone. Thank you, ma'am, and thank you all the participants.
Bye.
And stay
Thank you,
safe
ma'am.
and
Thank
take
you.
care.
Thank
Have a
you.
good
Thank
day.
you, Harsar. Bye bye.
Bye.